time once again for Community Forum, and we are very lucky to have with us live in the studios this morning Kristie Ebi. Kristie Ebi is a University of Washington professor in the Department of Global Health and Environmental and Occupational Health Sciences, and she is one of the co-authors of the just-released UN Intergovernmental Panel on Climate Change Special Report on Global Warming of 1.5 degrees Celsius. Kristie, thank you very much for coming in and spending time with us this morning.
Thank you for having me.
So start out, tell us what was the motivation in producing this latest report?
This is the very first report that the United Nations Framework Convention on Climate Change specifically asked the Intergovernmental Panel on Climate Change to produce. There are 30 years of assessments produced under the Intergovernmental Panel on Climate Change, but this is the first time that this body was asked to produce an assessment specifically on the question of what are the risks of warming of 1.5 and 2 degrees Celsius above pre-industrial.
All right, and so summarize for us, what did you find?
There's a number of key findings. The first is that climate change is already affecting people, ecosystems, and livelihoods. So there's already impacts that can be observed and can be attributable to climate change. The second is any additional unit of warming it's projected, doesn't have to be is projected to cause increased impacts. So we'll see greater impacts at 1.5 degrees versus even greater impacts at 2 degrees. So the risks continue to go up. The risks don't necessarily go up linearly. They can go up non-linearly. So the projections are increases in significant risks in many places for many systems. Another key message is there are literally thousands of options to reduce our greenhouse gas emissions and to help individuals, societies, and nations better adapt to the projected risks. And in fact, if we take those actions, I'll do these one at a time. So if we take the actions to better adapt to a changing climate, we can prevent some of the risks that are projected. In other words, they don't have to occur. I'll give an example for that is heat waves result in deaths. Nobody has to die in a heat wave. People do die in heat waves. Heat wave early warning systems save lives. So if heat wave early warning systems were more broadly deployed, and if we did some work to make sure their uptake was better, they'd be effective today and they would be effective with higher temperatures. So there's lots of options available to reduce the risks. The other part is reducing our greenhouse gas emissions. So a key message from the report is it's urgent that we reduce our greenhouse gas emissions, and that the physics and the chemistry of how the climate system works means, in fact, we could keep, collectively, global mean surface temperature below 1.5 degrees Celsius above pre-industrial. There's no constraints. The constraints are political constraints on ensuring, in fact, that we reduce our emissions quite quickly, that we transform our energy sector, we rethink how we do transport in major cities. The final part of that message is that for these mitigation options, almost all of them have significant health co-benefits. Reducing emissions out of tailpipes, reducing emissions out of coal-fired power plants, it takes particles out of the air. 7 million people worldwide die every year from air pollution. So if we could reduce these emissions, we would benefit our health now, and we would ensure that the climate doesn't warm as much as it's projected to if we continue to make those emissions.
So up to this point, we've been looking at a 1 degree Celsius increase since Industrial Revolution?
That's right. The world's already increased 1 degree. And of course, it's 1 degree averaged around the world. It doesn't mean it's 1 degree everywhere. So parts of the world have warmed significantly more than 1 degree, and parts have not warmed as much. That's also true for the projections. So when you're looking at projections of an increase of 1.5 degrees Celsius above pre-industrial, The Arctic is going to warm a lot more than that, but parts of the ocean won't warm as much. So there's a lot of variability in what the local temperature changes are projected to be.
So just based on the 1 degree increase so far, which I guess was what the bulk of your data would have been using.
Yes.
What have we seen within that you already find significant and or disturbing?
We're already seeing increases in the frequency and intensity and duration of extreme events, particularly heat waves. There's been a lot of discussion about hurricanes and how hurricanes are changing because ocean temperatures are higher, that hurricanes draw their energy from the temperature of the ocean. So we're seeing people dying in heat waves. We're seeing vector-borne diseases change their range. We're seeing die-off in some ecosystems. We're seeing places where it's much more difficult for people to achieve their livelihoods, parts of the low and middle income countries where it's becoming hotter and drier. The crop production is falling, which makes it more difficult then, of course, for people to make the money they need to make to feed their families and buy their inputs for agriculture. So there's lots of changes taking place on land. And in oceans, we're seeing ocean acidification, we're seeing significant changes in corals. So there's quite a broad range of changes that have already occurred with a 1 degree increase in global mean surface temperature.
I think we see regularly in the media and corporate media what many would perceive to be tied to the climate change, the increase in temperature. So how do you factor in when this large body of scientists that you had participate in this report, instances where, let's say with vector-borne diseases, changes in that based on the change in temperature versus just human interaction?
It's a good question. It's very complicated to do that. There's a field called detection and attribution, where people do exactly what that implies. They detect whether there's been a change from a baseline. It's easier with our weather observations because it's easier to construct baselines. It's more difficult when you're thinking about, for example, malaria changing its range, because what is the baseline? So there's a lot of work that has to be done around looking at baselines. And if you do see a change from the baseline, then what portion of that change could be due to climate change versus better malaria control programs versus other kinds of interventions? So for some areas, it's more difficult because of this complex interaction of factors. In other areas, it's a bit easier, particularly when you're looking at a rare disease, for example, and seeing a sudden shift in that disease that you can directly attribute to a change from temperature. A couple of years ago, the Baltic warmed just phenomenally. Parts of the Baltic warmed, I think it was as much as 10 degrees above normal. And there were outbreaks around the Baltic of a series of diseases that are called Vibrio. There's Vibrio parahemolyticus, which causes really nasty gastrointestinal disease, Vibrio vulnificus. Anyway, they had not seen cases, or if they had seen cases, they were very small numbers, and they saw much larger numbers of cases all the way up towards the Arctic Circle in places that you would never expect that you would see this. It's because the temperature in the Baltic was so high that these organisms could replicate. So you have many places where you can say, yes, climate change did contribute, and others where it's consistent with what you expect, but yet you don't have quite enough data to take a look at the various interacting factors. So talk about the increase when you talk about heat waves and the increase in temperature. Obviously, that's going to affect the land itself. As it gets warmer, then we have less, it retains less water and moisture in it, right? What happens is warmer air holds more water. And so when you don't have rain, that warmer air pulls moisture out of the soil, which is how you then get drought. But when it rains, you see heavier precipitation events. In the U.S., there's already been more than a 20% increase in heavy precipitation events. It's not that it's raining more often, it's raining harder. I've only lived in Seattle for a few years, and I've listened to many people over the last few years talk about these unprecedented heavy rainfall events. That's exactly what you expect with a change in climate. So you see both more floods and more droughts.
Which we are seeing examples of, again, as you say, just here in Seattle.
Yeah.
More heavy downpours, hotter stretches during the summer. And we can expect more of that. We're seeing more of it. We can expect more of that. What's your predictions again for when we hit potentially, if we don't change now, both the 1.5 and 2.0 increase?
Because there's uncertainty in the climate system, there's a range. So the projection for when the global mean surface temperature could reach 1.5 ranges from 2030 to 2052. So, somewhere in the 2030s, 2040s is when it's projected the globe will warm that much, assuming we continue our emissions at the same rate. And then 2 degrees is highly variable when the projections for 2 degrees. If we don't reduce our emissions, then we could see that not long after we see 1.5. If you think today we've increased 1 degree, and we're talking about increasing a half a degree in potentially as little as 20 years, then another half degree could be 20 years after that. So very close in time. If we do reduce our emissions, we may never hit 2 degrees. We could push that out well past 2100. At the same time, it's important to remember that most of the energy, what we're doing with emitting greenhouse gases is we're putting energy into the climate system. And most of that energy is going into the oceans. And so the oceans are taking up most of this energy, and as a result, sea level rise will continue for thousands of years. So we can take action to reduce our global mean surface temperature. Sea level rise is just going to continue.
And if the oceans are taking the brunt of this, and most of it will be below the surface, we're actually not seeing a lot of what is happening currently, correct?
That's correct. There's a lot of research going on and understanding what's going on in the oceans, how the temperature is shifting, what that means for corals, what that means for fisheries.
So touch on the increase in heat, how that affects both humans, but it greatly affects animals as well as insects.
It does indeed. There was a recent paper came out showing a big decline in many insect populations, due probably to temperature, but for some of the species it may be because there's also changes in the humidity. But it's a temperature-driven response. So yes, we're seeing declines. I can remember as a child driving across the Midwest and having to stop regularly to clean off your windscreen because of all of the bugs, and how there used to be car washes where people advertised they would clean all the bugs off the grill in the front of the car. We don't have that anymore. So there has been a decline. I mean, it's just a simple example. It doesn't prove, but there has been a decline in a lot of the insects that we rely on. There's, of course, a lot of concerns about the bees. So there's lots of changes going on that are being measured that are directly consequence of the changing climate.
And a lot of people don't take into account that insects are actually key in the whole pollination of plants.
They are indeed. You can't get the plants. Very few plants self-pollinate. They need something to help them with the pollination process. And those somethings are insects and bees, right?
So, and then it obviously is going to affect animals, and some of those are, in addition to we perceive as just being there for our visual entertainment.
Right.
Some of them are animals we consume and are quite critical to the ecosystem as well.
Yeah, that's correct. There's been a big changes in animals. Everybody knows about the polar bears. And with permafrost, they're just losing the land that they need to be able to maintain their lives. That you now see these photographs of polar bears that are incredibly skinny because they just can't get enough to eat. But it's also affecting the domestic animals. And it's a broad range of issues. We talked about heat for a little bit. Turns out chickens don't like heat very much. So if chickens are not kept in air-conditioned environments when there's heat waves, mortality in chickens can be quite high. There's also a different mechanism that's going on, that the carbon dioxide we're emitting itself is affecting our plants. So this is separate from the temperature change. There's different categories of plants in terms of how they take carbon out of the atmosphere and use it to grow. And there's a category of plants that include most of the cereal crops we rely on, particularly rice, wheat, potatoes. And as the carbon dioxide increases in the atmosphere, the way these plants respond physiologically results in the plants having less protein, they have less micronutrients, and they have less B vitamins. So the nutritional quality of the plants is going down. It's really important for low and middle income countries like Bangladesh, even as they're developing. Today, 3 of 4 calories comes from rice. There's about 820 million people in the world who are food insecure. There's about 2 billion who are micronutrient deficient, particularly iron and zinc. And iron and zinc is going down in the plants. And of course, we feed many of these plants to the animals we rely on for our food. And so the micronutrients come directly from the plants. So there's research going on showing, in fact, that cattle are changing in response to changes in their diet. There's some plants that are not being affected as much, but there are consequences throughout the food chain, not just for what we, the bagel or the donut you had for breakfast, but also what it means for what the animals are eating, and then how nutritious they are to provide whatever we need as humans in terms of micronutrients and B vitamins and protein.
So you have been working on this issue for a long time, like at least 20 years, is that right?
More than 20 years, yes.
Okay. So put it into perspective for us, where we are right now, how bad things are.
How bad things are in terms of
our soiling the nest and the chance to fix the nest we have soiled.
Reports have been coming out for 30 years on the challenges of climate change. This report is different, as I said, because it was asked for by governments. It also asks the scientific community to frame our questions differently than was done in the past. So when you look at the research that was done prior to this report, mostly people looked at what are the potential consequences in 2030, 2050, 2100. So it was looking at time. And this report said specifically, we want to look at temperature change. They are, of course, related, but it does give you a different perspective on the research that has been done in terms of the immediacy, because we now have stronger, more robust projections of when we could hit 1.5 degrees C in the 2030s, 2040s. And so it does give you a greater sense of the urgency of the challenge. It very clearly lays out the magnitude of that challenge and all of the options that can help us address the challenge. One of the really gratifying parts of last week in Incheon, South Korea, was the process to produce this report is a scientist write the chapters. The scientists then draft what's called a summary for policymakers. And when we met in Incheon, there was about 140 governments present. And you literally go through the summary for policymakers line by line, sentence by sentence. You put up the first sentence, 15 flags come up and governments say, I don't understand this. Or governments say, gee, in this chapter, on this page, on this line number, is a point that's really important for my government. Could we incorporate that in there? And so you sit and negotiate, you work directly with the governments to ensure that the summary for policymakers is consistent with the underlying science, but also written in a way that's useful for them as they go back and work on developing their policies. So it was a very intense week and very, very strong and very positive engagement from the world governments because they wanted the summary for policymakers to go back to their prime minister, to their Ministry of the Environment, to their parliament, to say, here's what this report says, and this is what we will need to do. As you go through this approval session, each sentence is agreed by consensus. Every government signs off on every sentence. And so in the end, the summary for policymakers is their document. We're happy with the science. It's completely consistent with what we have in the report, and it's phrased in a way that they can use to promote policy. And that kind of co-production of a document for policymakers is fascinating and a real privilege to be part of.
Can the 140 governments that participated in this program carry this on their own, or don't we need the other 50 that chose not to?
Yes and no. That for greenhouse gas emissions, the level of emissions is not the same everywhere. So there's a few countries that really urgently need to reduce their greenhouse gas emissions. If one country chooses not to, then it means other countries need to up their ambition. But don't forget, we're focusing here on national governments, but look at what's going on in the states, in the US, and in the cities. California, Governor Brown just committed to significantly reducing their emissions over a couple of decades. We've got a ballot initiative coming up. So the states are taking a lot of action, and that is true in every country. So you see a diversity across different scales of governance. And yes, we do collectively need to reduce our emissions, but I do a lot of work in small island states. Their total emissions are not very much. The other part of this is every country's got to work on adaptation. Because every country's being affected, they have to be much better prepared. Look at all the disasters we've seen this year and last year. So every country needs to work on that. Part of the negotiations under the United Nations Framework Convention on Climate Change is on providing funding for low and middle income countries to help them adapt better. They didn't cause this problem. Their emissions are quite low. So equity underlies this very, very strongly. And this document will go to the next meeting of the United Nations Framework Convention on Climate Change in December, and will feed into all of those negotiations around what's called loss and damage, around funding for adaptation, around the level of national ambition for mitigation reduction.
So in addition to a very busy week that you had dealing with the release of this report and your peers, I know that you've been doing a lot of media outreach or media outreaching to you. So what is your sense of how the rest of the world has taken this report versus the U.S. acceptance or non-acceptance of it?
Across the world, the media interest has been extraordinary, which is fabulous. So everyone I know is giving lots of media interviews, which is great. We really appreciate the interest in the report. When we all left Korea, co-authors, my colleagues, many of them flew back straight to their countries and went into meetings with their parliament, with their prime ministers, with their ministers of the environment, ministers of energy, whatever the various departments were, to present the report, talk about the findings, to talk about what needs to change in terms of their policies. So we're seeing very high uptake from many countries in terms of policy interest. We'll see what happens in terms of how long it takes for that uptake.
And how, I realize this isn't scientific, but how hopeful are you that we will, both as a country and or planet, address this crisis in time?
I would characterize all of the authors, I don't know whether they'd characterize themselves as this, as worried optimists. We're not paid to do this report. We have no compensation. I estimate I probably put 2,000 hours into this report. These are nights and weekends. And everyone put in those kinds of hours. And we did it because we're concerned, deeply concerned about what is going on with respect to climate change. And we have optimism that there is a possibility, if there is enough collective political will, that we can avert many of the disastrous projections that are out there. If you're too optimistic, you wouldn't want to spend a lot of time working on a report like this. And if you're a pessimist, you wouldn't actually want to engage in this report either. So you need that combination of deep, deep concern and some optimism that, in fact, this information can make a difference.
And finally, really quickly, what would you recommend to listeners to do based on what you found out in this report?
There's a bunch of things that people can do. The simple things of thinking about your energy usage, turning out the lights. Every parent says that about 1 million times to children. Saves you money, reduces energy consumption. Unplug phone chargers when you're not using them because they draw energy. Put your computer to sleep when you're not using it. There's lots of ways you can reduce your energy consumption. Save you money, it'll be good for the planet. Increase your own awareness, understand the range of possibilities for reducing your emissions. And then one of the most important things is we have an election next month. And if this matters to you, just like any issue that matters to you, then vote for people who will try and put the policies in place that we're going to need to address a changing climate.
All right. Well, with that, we are unfortunately out of time. I want to thank you very much for coming and spending time with us.
Thank you so much.